So when you are following the tutorial, there are two ways you can do this. One is you can uh, pull the repo from GitHub, make your modifications locally, and then push it back to GitHub, and GitHub will run its GitHub actions to compile and verify your design. If you want to compile and verify your design locally, you need to set up your machine with the required tools. The tools are freely available. I will show you how to do it on a Linux machine. The process will be similar for a Windows machine, and the installation process is given in the Cocotb documentation. So you can go to cocotb.readthedocs.io, and you have an installation link over here. Once you click on the installation link, you will get for different operating system what is the process. So we'll be following the process for Linux. I will just copy this. So in my case, everything is already installed. The next thing which I will do is I will install Icarus Verilog. Now finally I will create an environment for my simulation. So the way I do it is I say pip3 -m venv, and let me call the environment also as venv. So I'm creating a virtual environment. We are creating a virtual environment because we don't want our installation of Python libraries to go uh, into our main Python folders. We don't want to corrupt the main Python installation with it. Sorry, my command was wrong. It should be Python, not pip3, Python 3 -m venv. So what this will do is that it will create this folder over here, and if I say which Python currently, it is pointing to user bin Python. Now when I source venv bin activate, and now I can check which is the Python that is used. This is the local Python that we have that is being used. So any installation that we do now will not corrupt the global Python installation. So the next thing what we'll do is we'll install the required packages. So we'll install PyTest, we'll install Cocotb, we'll install Cocotb bus and Cocotb coverage. So this has basically downloaded all the required tools and put it under venv. So now if I look into venv lib Python 3.10 site packages, and I can see that Cocotb is installed, Cocotb bus is installed, Cocotb coverage is installed, and PyTest is installed. And now I can go to my test folder and run make. I will also cover the structure of the makefile for simulation. So the first line specifies our simulator, which we are set to declare as Verilog. Top level language, we are saying it is Verilog. Then our source file, we are declaring all our source file over here. So this creates a list. Verilog sources becomes a list of source files. Then we are defining a make target called OR, and in that we are calling make sim, passing a variable called module, which is the Python module, or test, and the top level, which is again or test, which is this Verilog file. And then we are including the Cocotb simulation makefile. So this makefile has the sim target. We always put this at the end of our makefile. The reason for that is that it has its own make target. So if I issue a make command without a make target, uh, make picks up the very first target that it sees. So if this is included before, it will see the make target from makefile and not from this. So whatever parameters we are passing, those parameters will not be passed. So this is one way in which you can run your simulation. The other way is at the base of your repo, we have created a folder called GitHub. So if you go into GitHub, workflow actions.yml, you don't have to touch any of the initial lines. These lines are basically for installing the required tools. Line number 11 basically says from the entry point in your repo, that is the root of your repo, go to directory tests and run make. So in our case, since we want to run OR target, we can even specify OR, but the way we have specified our makefile, the default target is OR, so that is not required. But if you have other targets as well and you want to run them one after the other or in some specific fashion, you can give the targets. And then we are saying that we want to upload an artifact named waveform, and that waveform will be present in tests wave.vcd. And once we provide this information and we push our repo, then whenever we do a push operation, an action will be fired. And if you look at what the action is doing, it is, this is the action that we just saw, where we had waveforms. We said make -c, pip install Cocotb, pip install iverilog, and what it basically does is that it checks out our repo, it starts a virtual machine, step 1, then it checks out our repo, once it has done that, it runs the commands that we have specified as run commands. So apt install, followed by pip3 install, followed by make-c, and once this is done, so here you can see test pass, what we are expecting. Once that is done, it will upload the artifact, which is our zip file, and that's it. And then it will clean up and it will exit from this. Okay, so these are the two ways in which you can set up your environment. One is locally on your machine, you can set up the environment, pull your repo. So for example, when we created this repo, for our assignment. So now there are two ways in which you can go ahead and you can start modifying stuff. You can come over here, come to this file duttest.py, and you can say edit over here itself. Okay, and let us say assert 1 equals let us say we say assert 0, and let give an f string. So let us say that this was what we wrote, and we go ahead and commit this change. So option 1, we see that it is firing. It is installing a cursor log, running make C, and let us see. Our test has failed. We had, and it has failed on this assert 0. Okay, so this is one way in which you can edit your code and check it online, and then you can download the artifact which is created. If artifact was created, you can download it. In this particular case, we have not created the wrapper file, so no artifacts will be created. You will see a message on the artifact side. No files were found at the path, so no artifacts will be uploaded, so no zip file will be created. The other way in which you can run the same thing is you come over here, SSH, copy this, and then say git clone whatever we had copied. This folder, go to this folder, then go to test, let us say I'm just setting it to say pass, run make, so this is the way in which we can do it locally. As well as once I have made this modification, if I push it, it will again run the GitHub action. So if you are using Windows and you have some problem installing Cocotb and getting it to work with Icarus Verilog, then you can always use the GitHub actions method to test your code.